let's see. All right, topic number 11. What are we doing? We are counting and massing atoms. That's the main goal for topic number 11. So you need to remember chemical reactions, hey, they occur at the atomic level. And what I mean by that is it's basically atom and atom. That's how things combine. And you have to remember it's atom and not a handful of this and a handful of that. That's how things combine. So an example. Look at this. Yes, I'm going to go to my M&M stash that I have in my house. So just pretend that this red M&M is an atom. And I'm going to take that atom and I'm going to combine it with another atom that is the same. And I am going to create a larger atom composed of those two. So here's an example. Let's say I take fluorine and I add it to another fluorine and I get a fluorine molecule that contains two atoms of fluorine. That's why I used a larger M&M. Okay, we could also have the same situation where I have two different atoms coming together. So I could have this blue M&M. Let me draw this line here. So now I take this atom and I add it to a different atom. And what I'm going to get is I'm going to get those two combined together. Yes, I did it right. Blue and yellow make green. So an example of this would be like table salt, where you have your sodium and you have your chlorine and you put the two together. And what you do is you actually form one molecule of these two atoms combined together. And that's why I used the larger green M&M. So you got to think of it this way, my friends. Whenever we combine things, it's an atom and an atom coming together to form some kind of molecule. It's at the atomic level. Well, there's a major problem. You can't physically grab an atom of fluorine and another atom of fluorine and combine them together. They're too small. So even though the world around us combines things atom by atom, humans can't do that. We can't take a single atom of something and add it to a single atom of something else. The only tool that man has when it comes to combining atoms is the balance, or a scale. And you guys know at your level that a balance can actually measure mass. Okay? That's the only tool that man has at his disposal when it comes to taking atoms and combining them together. But again, there's a problem with mass when it comes to atoms. So check this out. So let's say I have these four atoms. Let's say the combined mass of these four atoms is 5 grams. I am now going to combine those four with two different atoms at the same mass. Okay, now here's where you got to put your thinking cap on. Since these guys are smaller, I would get more of them in 5 grams, and since these are larger, I get fewer of them in 5 grams. But the key is they're both at a mass of 5 grams. If I do combine these, and just picture this this guy, these atoms are in a test tube, and this is in another test tube, and then you combine the two together and they combine. And let's say the ratio is a 1-to-1 combination. And I mean this. So this one atom grabs this atom of that guy and they combine together. This atom and this atom come together and combine and make this. So when I took these and added them to these, I made this. And if you look right here, there's one molecule of the combination, and here's a second. Now, here's the problem. I have extra. I have extra of these. You don't want extra of these. It's almost like if we were to make cookies, and you would flip it over and you would follow that recipe. See that recipe? Well, there's a reason why it's 1 teaspoon of salt, 1 cup of butter, 3/4 sugar, vanilla extract. You see all those measurements that they have? There's a reason why. They don't want anything extra. So even in baking, we have to be careful to use everything. Otherwise, your cookies are going to taste like, I don't know what they taste like. So what we got to do now is we have to change the amounts. Okay, so now watch this. Now watch this. So I'm going to go back and I'm going to grab these 4, and you're right, it's at 5 grams. But now if I want 4 of these big boys, hey, it ain't 5 grams anymore. That sucker's worth 10 grams because I doubled it. Now when I combine them, watch what happens. One of these and one of these come together. One of these and one of these come together. One of these and one of these, and one of these and one of these. Now I made 4. And look, no extra. So at the atomic level, all of them were used. Nothing's left over. But look at their masses. Their masses are different. So we can't just simply use the same mass because atoms are of different sizes. We have to use different masses, but the atoms are equal. And I'll tell you what, that was perplexing for a long, long time. It took scientists, as you can imagine looking at this, it took them a long time to figure out some system where they could relate mass to the number of atoms. It took them a long time. They finally did it. It was an Italian physicist named Avogadro who figured out how to relate atoms, the number of atoms in mass, to get something like this to happen. So without further ado and saving you 45 minutes of boring lecture on how they did it, I'm going to show you what they found. Okay? And it's going to solve this problem of different masses of different atoms, but the ratios all come out to be the same. So let me clear my board of my M&Ms that I get to eat at the end of class. All right, so what did they find? What system did they develop? All right, sit down and get comfortable because here it is. Grab that calculator because obviously we've got some math. Let me get rid of all this garbage. Okay, what did they find? This is what they found, my friends. If you have that many atoms of some particular element, the mass is equal to the A number. Now you have to go back to topic 3 about that A number. We used it way back in topic 3. Remember, the A number is the combination of the protons and the neutrons together, which are these numbers, if you recall from topic 3. No, we're not using the atomic number, the one at the top. We're using these. Those are the ones we're going to use from now on. You can just about kiss these goodbye. We're done using those. The rest of the year, quarter, is going to be focusing on these numbers. So pay very close attention to these. That would be the mass. That's your A. That's your A number, which is also called the atomic mass. And hey, look, it's in grams. Something that humans can actually measure. But look at the number of atoms it takes. Look at the number of atoms. That's a large number. Get out your best friend. Okay. Let me put this in something that is a little bit easier for you guys to use and follow. Well, before I do that, you see this number right here? Well, and don't laugh. No, I want you to laugh. Go ahead and laugh. I don't care. Get it out of your system. They gave this name a number. Or sorry, they gave this number a name. Like this. We could call 12. We could call that a dozen. We can call 2 a pair, right? We can call 10 a deca. I have deca M&Ms on my board. We got 10. All right, well, they did the same thing. They gave this number a name. The name that is applied to that nasty number is called a mole. I'm glad you're done laughing, because it's just it. So the German and Italian physicist who was working on this, if you translate how he described his work to English, it comes out to be a mole. It's actually called a pile, is what he used, because you need a pile of atoms large enough to mass, is what he was working on. So they gave that number a name. So now if you see a mole, the mole is that. So I could have 1 mole of M&Ms, and I would have 6.02 e to the 23rd M&Ms. And I would probably be in heaven if I had that many. If I had that many, it would probably reach to the moon if they were stacked one by one by one. That's a huge number, my friends. So I could have a mole of M&Ms. I've got this many. I could have, I could have a mole of pennies. I would have that many pennies. I could have a mole of dry erase pens. I would have that many. You just now have to add this to your mathematical inventory when it comes to numbers and a name. Add it right next to your dozen, which is 12. Okay. So let me relate this to something that you're going to use the rest of the quarter. Matter of fact, this is so important, I'm going to change colors. And maybe you want to write this on the back of your hand. I don't know. But here it is. Hey, here it is. 6.02 e to the 23rd equals a mole, which equals the A number. The A number in grams. I would copy that on the back of my hand and refer to that for the rest of the quarter. Why is that so important, my friends? We have put a number to the mass of atoms when they combine, which basically is the Holy Grail. We have found a way to keep track using mass, which humans can definitely measure, and atoms that we can't use directly, but we can count them by using this system. All right, and you're probably still confused. I would be confused as well, because this is a different little deal. All right, let me relate something to you, using your friend. All right, so watch this. Let me grab a different color. Maybe I use green. I don't know. All right, let me show you an example. How does green look? Oh, you can see green. All right, example. I'm going to pick one. I don't care. I'm going to pick any one. You want to pick that one? That sounds good to me. Okay. Come on, camera. You paid $60 for you, and oh, you just don't want to participate, do you? Hey, there it is. Okay. I'm going to pick magnesium. Okay, now watch this. Remember what we did in topic 3? I know it was a long time ago. With these A numbers, remember what we did? We rounded them off. You need to continue to round them off. You don't want to use this 0.3051. You're going to be here forever, my friends. We need to expedite this process. You will always round these red numbers off. Okay, so watch this. I'm going to pick magnesium. So, if I had 6.02 to the 23rd atoms of magnesium, that would be equal to 1 mole, which would be equal to, let's see, I need his A number, and that will turn it into grams. What's the A number for magnesium? You're going to round that off like you promised me you would. 24. Booyah. Hey, that's the key. Remember the problem that we had before with the M&Ms, where the atoms and the mass didn't work well together if the mass was the same? I got it now, man. I've got it now. If I have that many atoms of him, I can call that a mole, which would be that many grams. Okay, another one. I can tell. Another one. We haven't picked. Oh, hey, I think I still have them on my desk here. Where is it? Oh, yes! My piece of aluminum. Look at that. Beautiful, shiny metal. Okay, so watch this. All right, I'm going to grab a different color pen. All right, watch this. 6.02 e to the 23rd atoms. Now I want aluminum. Well, I know that's a mole because that's the name given to this number. Now I got a different element type. So now the question is, how many grams would I have? That's where you use this. And you simply find aluminum, and you grab that A number, and you, how close can I get this? And you round it to 27. 27. I would have 27 grams. Okay, now look at the correlation. Look at the correlation. Look how the relationship works. If I have this many atoms of aluminum, I already know that I've got a mole of aluminum atoms, and I already know the mass. So the relationship is a mole of any atom, of any element, there's your mass. You don't even have to go back in the lab of my room that you've never been in. Oh, some of you have. There's your mass. And yeah, if we were in my room, darn right, man, I'll have you guys out of your seats and you'd be practicing this in the back part of my room over and over and over again, because you can physically do this. Okay. All right, so find your table, and I want you to do this. I want you to do this. I want you to tell me if I had this many atoms. Okay, and now I'm going to pick one. Let's pick sulfur. Sulfur. I do have a mole. Okay, now what I want you to do is tell me how many grams I have. And I'll give you a little hint. Sulfur's sitting over here. Hurry, hurry. Yeah, you should be done by now, because it doesn't take any magical skill to look up sulfur and grab its A number. You don't have to. It's just look it up. So hopefully you had 32 here, because that is the A number for sulfur, and it is grams when I have this many atoms of it. Okay, now I want you to do this. I want you to do this. If I had 1 mole, and now I'm going to put the element symbol here, and I want you to figure out what it would be on either side. So let me do this. Let's grab sodium, Na. Okay, what I want to know is how many grams and how many atoms I would have. See how I'm just kind of go back and forth? I've got basically 3 sections. Well, if I just know one of them, I can find the other 2. I'll give you a quick hint. You better hurry up. Na is over here. Okay, the key is I got 1 mole of it. How many grams would I have? How many atoms would I have? Hurry. Okay, you should be done. So, here's what I do. If I see 1 mole, I know already how many I have. I know I have this many. I know I have that many. And if I have that many atoms of a particular element, I already know the mass. I just simply use this. And I got it. I'm going to round. My camera does not like the, oh, look at that. I can put that in a light box. Round that off to 23. I already know. I already know. Okay, so look at those 4. Look at the relationships. Come on, look, you're smart. Come on, look at the relationship. Okay, that's a good question. You asked me what I see. Well, this is what I see. I see that the mass is going to change based on the different elements of choice, but the number of atoms is always the same. And that goes back to when I had the orange and blue M&Ms and I took the 4 and the 2. Remember this? Remember this? And then we found out that I had extra, I had extra orange M&Ms, and so I said, well, that's not going to work. What I need to do is get this situation to show up. But then I told you the masses. I said, hey, this is worth 5 grams and this is worth 10 grams. But look, in these 10 grams, I got the same number of atoms as I do of these with 5. See the number of atoms right here? See these masses, how different they are? They're different. Yeah, you got to really wrap your head. This one takes a while. This concept takes a while. Okay, so, come on. You guys know the real world doesn't work this way. It doesn't work out this way. Look how perfect this is. Hey, look how perfect this is. It's never that way in the real world. So now you're going to have situations that look like this. Don't get mad at me. Remember, I just work here. Don't get mad at me. But let's say that I'm back in the lab and I don't have an exact mole. Let's say I have 0.5 moles. And I always have to give you the element. I have to tell you what that is. So I'm gonna pick scandium. Now look at the question. Now look at this. How many grams would I have, and how many atoms would I have? Okay, I'm going to give you just a few. I'll give you a minute. I'll give you a minute. Think about what you would do to solve for those two spots. But now I don't have a mole. Think. Okay, so let's see what your thought process was. What was my atom? Oh, scandium. There he is. Look at that A number. Rounded off is 45. 45. Well, let's see. If 1 mole is 45, but I only have a half a mole, that's half of that. What's half of 45? What, 22.5? 22.5 divided by 2, 22.5. Okay, well, that's nice. I've got 22.5 grams. Because I got a half a mole of that substance. Oh no, what the heck happens over here? Well, if 1 mole is that many, but now you have 0.5, now how many would you have? Welcome to your third best friend. I think you better grab this thing now and see if you're using your phone, that's fine. You better practice using your phone and compare it to my answer. Okay, I'm going to show you what we're going to do using this calculator. Alright, so yes, I'm basically going to divide this in half because I cut this in half to get 0.5. I'm going to cut this in half to get 0.5. Now, here's how you type this thing in. You type this in incorrectly, it's over. Alright, so here's what you do. You type in the 6.02 first. 6.02. Alright, on my calculator, I am looking for, there it is, right there. You see those two EEs? It's a double EE. That double EE is this part right here. Because remember, that's powers of 10. That's your scientific notation that I covered with you in topic 2. So what I got to do now is I got to press that EE, which is going to force me to press the second shift button and go here. Now look what my calculator shows in the display. Okay, it's waiting for me, if I can get it to look just right, it's waiting for me to type in the exponent part. Well, I'm going to type in 23. I'm going to type in 23. There. I wonder if you can see that or not. There it is. Okay, so now I'm going to divide it by 2 because I cut this in half. I cut his red number in half. I'm going to divide this by 2. So I'm going to press divide and I'm going to type in 2. And bada boom, bada bing. If you can see your value there. So honestly, I'm telling you, I've done this for 50 years. You better try this. I've seen students not try this, and then later on they try the assessment, and they don't know how to use their calculator on their phone because they didn't try it now with me to see if they could figure it out. So based on my value, I get 3.01 E23. I really hope you try this in whatever calculator you are going to use and see if you got that. Because I have seen over my 60 years of teaching chemistry, I have seen those phones cause a problem when we have to use exponents. And if that is how you're going to do your assessments, that's going to be your grade, and it's not working right, that's what it spells. I have seen it millions of times. So please, try it. Okay? All right. Are you ready for the next part? Yes, you are. Thank you. Listen. My mom can divide things in half. 1 divided by 2 is that. That divided by 2, okay, she might have a hard time typing that in. She's 86. She might have a hard time typing that in a calculator. My mom could take 45 and divide by 2. Now, this is not the real world, my friends. That was an easy, I'm going to cut it in half. Well, that's not the way the world is. I think you better sit down for this. Here's the problem we're going to have. Let's say I give you 0.65 moles, and I'm going to pick iron this time. Yeah, now you're going to want to cry. 0.65 moles. You could still figure this, and you could still figure this. But I tell you what, that's a different little trick there. That's not as easy as this. You're going to have crap like this, and it's going to get worse than this, my friends. So how in the world would you solve something like that to get the mass or the atoms? Well, this goes back, and this will probably make you want to pull your hair out. This goes back to our very first topic of the quarter, back to topic number 1. What did we do in topic 1? We built bridges. And in topic 1, we were converting metric stuff, like 200 millimeters. This would be a single bridge. Remember, you put the millimeter down here, and let's say you wanted kilometers here. You have to look at these two and find out which one is the larger unit, which was this, because kings have diamonds and diamonds cost millions, was the scale that helped you get these numbers. And then you'd count the number of spots, and you get like 6 spots, which is, remember that? Yeah, well, guess what? You're using that now in topic 11. But here's what sucks, my friends. You don't have a scale like this to use when it comes to stuff like this. So, bye-bye, that's gone. Now what you've got to do is you will have 2 units, and you better know which one is a larger one, which I'll show you my little shortcut. But now you don't get these simple numbers of 1 and then a bunch of zeros. You get stuff like this tucked in here. And then, believe it or not, you got to build these bridges, and then these things start showing up. Okay, so I'm going to go, I need to erase this. Don't get mad at me. I need to erase this and I'm going to bring it to the top of the board and show you how I would use the bridge system on something as nasty as this. Alright, so I'm going to scoot this back up. Boy, I hope you have that somewhere on the back of your hand. Okay. I'm going to get rid of this. Okay, what was my question? My question was, how many atoms? And I already told you it's iron, so it's Fe. I'll put Fe here. And our one number was like 0.65 moles. And again, it's Fe. And then the question was, well, how many grams would that be? And again, it's Fe. You see, you have to have your element in all three spots. Okay. All right, now I can get rid of this down here. Sweet, let me build you a bridge. Oh, come on, the bridges are fun. I like doing this. Okay, pay close attention to what I would do. I don't care. I really don't care. I can go over here and do this one first, or I can decide to attack this one first. It's up to you. The main thing is, once I have moles, it's easy because I can go left or right. So let's go back over here and grab this one. Let's get this question mark taken care of. I think if I were you, I would just watch and listen carefully to how I build this bridge. Back in topic 1, I told you always take what they give you. And I said back in topic number 1, I said always take the number they give you and the unit, like millimeter, kilometer. Well, now is moles, grams, and atoms. And here you have to add a next piece, which is the symbol of the element. Now you have to add this to the bridge. And I'm going to build my bridge. I can't draw a straight line to save my life. Back in topic 1, I told you, hey, underneath here, let's just do this. Because remember, we want a number in each spot. All right. Back in topic 1, I told you, oh man, hey, whatever you see here, just copy it down here. Because the goal is to get those units to cancel. And that's exactly what I'm going to do. I'm now going to copy this down here, and my goal was to find the number of atoms. Bingo. That would be my next part of my bridge. Copy this down here. Get whatever you want goes on top. Now watch this. Before, I just used the kings have diamonds to help me get these numbers. You don't have that now, my friends. So how do you know which one of these two is the larger unit? Well, I'll tell you which one's the larger of the two, and it'll be that way the rest of your life. This is going to be our largest unit ever. This is the guy right here, the mole. So whenever you see a mole in a cell of a bridge, that guy will be the largest one. So I see that, I do that. And if the mole was on top, the 1 would be on top. Back in topic 1, we had to figure out, okay, if I had a kilogram, how many hectograms are in there? And I would simply count the spots. Well, this is actually a lot easier. If I have 1 mole of Fe, I already know how many atoms I have because you wrote that on the back of your hand. Because you already know it's this number. That's why I told you, write this on the back of your hand. Excuse me. Now I got it. Back in topic 1, I said, dude, your math skills are so good. You guys can handle this stuff. You're better at this than I am. Remember, you always go across the tops first. So let's do this in the calculator. Remember, this part of the bridge turns into a multiplication. So, in your third best friend, let's take 0.65 times 6.02 times 10 to the 23rd, and let's get our top number. I hope you're trying this. I hope you're practicing these problems as I do them today on the board. Okay. That was your little angel on your shoulder whispering to you, you better be doing these. Okay, so I'm going to take 0.65 and I'm going to times it now by this number. You have to know how to put this in a calculator. 6.02. I want to get to that double EE, so I'll press second. I got the double EE, and now I'm typing in 23. Oh, look what my calculator gives it. It's kind of hard. The camera doesn't like glares. Oh, I'm not going to move my hand now. See that? Got it. Got it. 3.913. 3.913, and don't forget this part because I see that on my calculator. That's sitting in the back corner. That's sitting right here. You have to read your calculator. I don't know what you're using. If we were in my room, you would all have the same calculator. It's so much easier to teach that way. Okay, there's my top number. And just like back in topic 1, I told you, okay, hey, let's do the bottoms next. 1 times, I'll do this one for you. 1 times 1. Units. Great question. Hey, what's a mole times atoms? You're right. It's mole atoms. Okay, and this is not going to fit. Don't laugh at me. What's the bottom unit that goes right here? It looks like it's 1 times a mole. Well, that means a mole goes down here for the unit. Remember, the goal is to get these units to cancel. I see a mole on top, a mole on the bottom. Gone. The only unit that's left is atoms. But you have to complete this math. Yes, I know, it's easy. 3.913 divided by 1. That is 3.913 e to the 23rd. And that, my friends, is the wrong answer. You can't record that as your final answer. Now that you're glaring at me and unhappy with me, you know why that's not your final answer. I didn't do this in topic 2 for nothing. I told you in topic 2, this is never your final answer. Because your calculator does not understand significant digits. Oh, that's why we did topic 2. Hello, I told you all my topics relate together and you use them forever. This is the incorrect answer. You have to convert it to the proper number of significant digits. This, my friends, is a counted number. You don't use this in your final answer. So that's a counted value because it's a mole number. Like 12 is a dozen. 12 is a counted number. If I had a dozen donuts, I got 12 donuts. I counted those donuts. There it is. this is the one you will use. So now you go back to topic number 2 and go, hey, how many significant digits are here? Well, according to the rules that your teacher actually printed and gave you, you would go, hey, there's 1, 2, there's 2 sigs there, which means you get 2 sigs here. Always start on the left, work your way to the right. There's 1, there's 2. I gotta do some rounding. Oh God, here comes topic 2 again. I gotta do some rounding. What's the 1 do to the 9? Nothing. I'm playing this rounding game to the right of the decimal. This all sounds familiar, doesn't it? I bet it does. This rounding game is playing to the right of the decimal, which means I erase these. I do not turn them to zeros. You have to erase. And so you get rid of this. You get rid of this. That was unchanged. Don't touch this, and don't forget the unit. That's your final answer. Topic number 11 can be a major beast, because topic number 11 requires you to use topic 1, topic 2, topic 3, topic 4, and I hate to tell you this, the topic you just finished, topic 10, boom. Oh, that's coming in too. Your naming skills better be up to par, or you're going to miss them all in topic number 11. What do we do? Hey, we just found this, which is this. Okay, now watch. Pay attention. Watch. I want to take this value, this number, and put it right here. 3.9 e 23rd. Okay, so 3.9 times 10 to the 23rd atoms of iron, yes, does equal 0.65 moles, but how many grams? This is the most important one, because this allows you to actually run an experiment, which obviously we can't do in this distance learning model, but it would allow you to do that. So, hey, we got to finish this now. We got to finish this, so let's go right here and let's do B. Always use the mole value. Hey, this is the key, because if you're in moles, you can go atoms and you can go grams, and just like that, you build another bridge. So let's build another bridge to get this into this. How do I build that bridge? Same way, man. I'm going to start with what they gave me, 0.65 moles Fe. Okay, I'm going to build my bridge. What number goes down here? 1. That's my very first step. Step 2, I like to deal with the units. And why? Because I'm going to copy this down here. Moles Fe. And I told you, what you want goes on top. That's what I want. I want grams of Fe. Third step. Crap, I need some numbers. I need some numbers. And no, you don't have that kings have diamonds anymore. You have to know which one is a larger unit. And like I told you up in this example, there is no question. You see moles, I don't care where moles shows up. You give that top dog that 1 value. I don't care where it is. This is one of those always things that students like. See that? Always. How's that? When you're in the conversion part, well, you might not start with that, but okay. Now, if I had 1 mole of Fe, how many grams do I have? Think about how you would get this number. Think. Hurry. Look at the back of your hand. Oh yeah, there it is. Remember, this comes from this. So now in a bridge, if I see grams in the same cell of a bridge with moles, dude, you'll watch me grab this faster than you can blink your eyes, because I know it's on here. And so what I do now is I look up Fe. I get his A value, which came from topic 3, which goes right here. Okay, my camera never likes the middle part of this table. Okay, there. Okay, I'm going to take that. That's the A number. I'm going to take that and round it to 56. 56 goes right there. How is that possible? Well, 1 mole of Fe atoms is equal to its A number in grams. That's the very first part of today's lesson. That's it. Now I'm going to play a math game. Hey, I'll do the bottom one for you. 1 times 1 is 1. Oh crap. Okay, let's go. We gotta do the top. Get out your calculator. We gotta do this. And multiply straight across. Let's go. Okay, get them out. Clear that garbage. At least this is an easy thing. You've done this a million times. This always causes a problem in the calculator. This is a lot easier, so this is easy. Hey, 0.65 times 56. There's my answer. 36.4. What was that? 36.4. 36.4. Units. What's going on? Moles times grams. Well, those are different, which means they stay. I'll just put G there. What's the unit in the bottom? 1 times mole. Looks like the mole grabs that bottom spot. Canceling units, if one's on top, one's on the bottom, they're the same, they're going to cancel, which means he's gone, he's gone. Hey, grams is left. That's nice. That's what I wanted. That's what I wanted. Now I get 36.4. And it is of Fe, because it's iron. And don't get mad at me. That's wrong. I shouldn't say it's wrong. Yeah, it's wrong. Yeah, it's wrong. I'll tell you the truth, it's wrong. Remember, topic 2, this is never your final answer. This is never your final answer when we are dealing with measured values by humans, because there's error in every type of tool that we use. Okay, listen carefully. Listen very carefully. These red numbers, these A numbers that we use off of here, we have rounded these. We have butchered these. I'm talking about the A numbers. We butchered these. So we're not going to use them to determine the number of significant digits. College, you use every decimal number there is. College, they'll slap you with this, and by God, you better use that 0.845, and you better count that in your significant. Yeah, I'm nice. Believe it or not, I'm a lot nicer than what you would have in college, trust me. So, don't use the A value when it comes to significant digits in my class. Go back to your original data given, which was this. Remember, I gave you that originally. That determines the size of this number in the end. Play your topic number 2 game. Go back and look. Hey, in here, how many significant digits do I have? That is significant. That is significant. Looks like I got 2 sigs here. Go to your answer. Okay, I need 2 sigs. Start on the left. Work your way to the right. and start counting significant digits, which in this case, that 3 is one of them. Here's my second one. You always go over one more spot, and there it is. What does a 4 do to the 6 for rounding? It does nothing. Okay, I'm playing the rounding game to the right of the decimal. Do I turn that to a 0 or do I erase? You see why I gave you those rules back in September? That you have to erase, and don't turn it to a 0. You would do this, and then you would do this. That's your answer. So you take this 36 and you go up here and you do this. 36. There's your answer. .9 times 10 to the 23rd atoms of iron equals 0.65 moles, which equals 36 grams. Those, my friends, are all equal to each other. 3 different units, all have the same relationship. Pretty cool, huh? I know you don't care about this, but I love this is pretty cool stuff. I love doing this. Okay, so you're thinking, oh my God, what's next? Well, I think for the first time on this topic, I'm just going to give you an example problem. I think I would love for you to work it out, and then we'll call it a day for today. This is a lot all at once. Okay. Just try these. Just please try to get as far as you can on these. Okay, so let's do this. Let's do this. Let's do this. Okay. Here you go. Look at this. How about 2.3 e to the 20th? We'll stick with atoms. Let's use aluminum, since you guys know where he is at on the table. All right, it would be wonderful to know. It'd be wonderful to know how many moles. And, that's of Al. And it'd be wonderful if you could calculate the grams of aluminum. So, go. Give me an A. Give me a B. I want those answers. I want you to build me some bridges and get the answer. I will tell you this, my friends. You always want that mole number, because you need this to get to him. Now, if you look at the order of this, you can't go from atoms all the way over to grams. You can't. You've got to get to moles first. Moles is the key. Once I'm in moles, then I can calculate the grams. So I'm going to give you a hint on this one. Your part A, I would convert atoms to moles. Okay, that's what you're going to do in A. And then B, once you get the mole value, use that to get the grams. There. And then at the end of today, I will give you my little flow chart for success. So you definitely want to hang out and pay attention for that. I'll save you hours worth of work. Okay, all of you, go. All right, I'm going to start here on A. I know I got to build the bridge. I'm always going to take what they give me and start the bridge. So I'm going to start it this way. I'm going to take this 2.3 e 20th atoms, and I want aluminum this time. Okay. Yeah, there's there's step 1 of my bridge. Step 2 of my bridge, I deal with the units. Hey, atoms has got to go down here so it cancels. And I want moles, so I'll put moles here. And it's aluminum. That's my step 2. My step 3, I need some numbers. Don't have a nice kings have diamonds scale to use. I got to use a new scale. Remember, I told you, if you see moles anywhere in a cell of a bridge, I don't care who he's compared to, wherever you see him, you always plop the 1 in front because he is the king daddy. He's the boss, number 1. Now the question is, so in 1 mole of aluminum, how many atoms would I have? Well, just look at the back of your hand. And the answer is sitting right there. Oh yeah, I've got this on the back of my hand. 23. Tops, bottoms. Let me multiply the tops and bottoms. Yeah, this one is very easy. Well, that times 1 is still 2.3 e to the 20th. Atom times mole, well, that's atom mole. Those two guys survive. The bottom, look at this. 1 times 6.02 is still 6.02. And looks like atoms will be on the bottom in terms of units. Hey, I can cancel those 2 out. Those are gone. Mole's going to survive. And I know that it's aluminum. Now in my calculator, 2.3 times 10 to the 20th divided by 6.02 times 10 to the 23rd. Bada boom, bada bing, bada bam. Oh no, did you see this number? Oh my goodness. That's wrong. Well, I shouldn't say wrong, it's just not the right one. Significant digits, no. We'll have to start with what they give us. So I see that there's 2. You know, and that's going to be the rule. The rule is just always use the given value for your SIGs. It's so much easier than you guys going, okay, so what do I use? I'll tell you what to use. Always the original value. Always. No matter where it is, use the original value and you're good to go. Okay, so I see there's 2 here. There's 1, there's 2, there's 2 SIGs. Significant digits start right here. There's 1, there's 2. Here's that 3rd extra spot. What's the 2 do to the 8? Nothing. The game is being played to the right of the decimal, which means erase, erase, erase. There's your answer. There's your moles. B. I told you. Go moles to grams. All right, watch this little nasty. No. You don't go grab this to start with. I'm telling you, start with moles and go to grams. You better grab this to start with. I'm going to grab this and build a bridge with that. And here comes my bridge. That's step 1. Step 2 of the bridge. I'm going to copy this down here. What do I want? Hey, I want my grams. I want my Grammys. Because now I know this was 0.00038. I want my Grammys, and so I'm going to put grams on top. Here you go again. Which one's larger? I told you, whenever you see a mole in the same cell of a bridge, give it the top dog one. That's it, every time. I don't care where it is. Top, bottom. Oh crap, slow down. Hey, 1 mole of aluminum has to have a certain mass, and that mass is equal to its A number. Round it off. 27. I'm going to put that right here. And I'm going to grab my 5th best friend, and I'm going to solve this baby right now. I'm going to multiply the tops. This times 27. Whew, good heavens. 0.00038 times 27. Got it. Looks like that top value is 0.01026 mole times gram. Mole times gram. Oh, I love the bottom. I love the bottom. Look at this. Look. 1 times 1. And it looks like 1 times mole is a mole. And then I always cancel them out to see if I'm on the right track. And I see mole on top, mole on the bottom. Bye-bye. Grams is left. What's my number? 0.01026. But I know that's not my final answer. I have to go back to the original value. Don't use these. I'm going to tell you, it's always the original. Not significant, not significant, not significant. 1, 2. You've got 2 sigs there. Going down here to this thing, that 0 is not significant. There's 1, there's 2. Here's that extra spot. What does that 2 do to that 0 in terms of rounding? Nothing. Where am I playing the game? To the right of the decimal, which means when you're done, there's your answer. Well, I'm going to scoot the G over here. There's your 2 significant digits, and it is of aluminum. That goes right there. Now, don't worry, you probably got it wrong. It's your first time. This is going to take you about 4 weeks to figure out. And by that time, quarter 2 is over. That's okay. That's how it works. No, just kidding. You need a lot of practice. All right, so I promised you the ultimate secret. Here it comes. Here is the ultimate secret flowchart. Don't spread this to other people. That's probably not the appropriate thing to say nowadays. Okay, never mind. Watch this. Here's the ultimate thing. Moles is the key. Grams is something we're going to want to use. We know we have atoms. Okay, watch this. This is probably the most important thing. When you see these 3 in any bridge, here's the numbers that you have to use every time. If I see atoms in a bridge, it's always going to be this value in the bridge. What value does mole receive when he's in the bridge, in a cell of a bridge? I told you, 1 every time. This one's going to drive you crazy because it's different every single time, because each atom has, or each element has a different A value, suckers. A different A value. So you have to use the A value for whatever atom you're on, which is also called the atomic mass, which means you better get your eyes on the periodic table. After a while, students love to see this because they know what number to give him, and they love to see this because they know what number to give him, and then this drives them crazy. Then they hate me for a week or 2, but it's not my fault. It's a table's fault. Okay, so obviously something's missing. Something's missing right here. That, my friends, is the next time I see you. I'm not going to give you any hints. And with that, I think we better stop. Boy, that's my longest period of the year. I've never used the entire time. Okay, I know it's a lot. Just let it soak up, and then we'll do more of this obviously on Thursday, and probably more of this on next Tuesday. Okay. Have a great day, my friends. Enjoy your advisory class.